All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on conditionals. Conditional All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on conditionals. Conditionals, or conditional statements, in Python and in other languages, are this ability to ask questions and answer those questions in order to decide, do you want to execute? All right. This is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on conditionals. Conditionals, or conditional statements, in Python and in other languages, are this ability to ask questions and answer those questions in order to decide, do you want to execute this line of code, or this line of code, or this other line of code instead? They allow you to take the proverbial forks in the road line of code, answer those questions in order to decide, do you want to execute this line of code, or this line of code, or this other line of code instead? They allow you to take the proverbial forks in the road within your own code logically. So how might we go about making some of these decisions? Well, it turns out that Python comes with a lot of built-in syntax. For instance, here are just some of the symbols you can use in Python to ask questions. Admittedly, mathematical questions, but we'll start there if only to keep the example simple early on. This first symbol, as you might know from math, represents greater than. This second symbol might not look too familiar because we usually write it all as one thing on a piece of paper. But on a keyboard, if you want to say greater than or equal to, you'd use this symbol instead. This, of course, means less than. This means less than or equal to. And this one's a bit of a curiosity. We've seen in our look at functions and variables how we were able to assign values to variables using a single equal sign. But that equal sign didn't represent equality. It represented assignment from right to left. That's great because it solved that problem, but it kind of left us in a bit of a bind because how do we now compare two things left and right? Well, in Python and in many languages, you actually use two equal signs. So two equal signs represents equality, comparing the thing on the left and the right. One equal sign, as always, represents assignment, copying the thing from the right to the left. Lastly, this last symbol represents not equal to. So the exclamation point or bang followed by an equal sign means not equal to some value next to it. Well, to ask the questions using these symbols or any others, we're going to need another keyword in Python. And that keyword, quite simply, as in English, is if. You can ask questions in Python code along the lines of, if the answer to this question is true, then go ahead and execute this code for me. So let's go ahead and write some of these examples here. I'm going to go over to VS Code, and let's go ahead and create a program first called compare.py. The goal of which which is simply to go ahead. So let this question is true, then go ahead and execute this code for me. So let's go ahead and write some of these examples here. I'm going to go over to VS Code, and let's go ahead and create a program first called compare.py. The goal of which is simply to write code that compares values and makes decisions based on those values. Let's go ahead and type code of compare.py in order to create a brand new file called compare in which we'll start to express some of this logic. All right, well, what do we want to compare? Suppose we want to compare, for the sake of discussion, just a couple of integers, but we'd like those integers to come from the user so that we can make decisions based on numbers we don't know the values of in advance. Well, let's go ahead and do this. As we've done in the past, let's declare a variable like x. Let's assign it equal to the return value of the int function and pass to the int function the return value of the input function, asking the user a question like, what's x question mark, as we've done in the past. Let's do this one more time with y, asking the user for the value value of y, and again, converting that ultimately to an int as well. So at this moment in the story, we have two variables, x and y, each of which has values. And ideally, we should be able to now compare these values. So suppose I want to make a decision based on the values of these variables. I'm going to use the keyword if, and I'm going to use some of those mathematical symbols to actually ask the question itself. So how about this? If x is less than y, then let's go ahead and just print as much out. Quote unquote, x is less than y. So this isn't a very interesting program yet. I'm literally just stating the obvious based on the math, but it's allowing me to now introduce some new syntax. And exactly what is this syntax? Well, it's this. Not just the keyword if, which I've added here at the start of line 4, but then I ask my question here. X less than y. X is one variable on the left, y is one variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. A Boolean expression named after a mathematician named Boole is simply a question that has a yes or no answer variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. A Boolean expression named after a mathematician named Boole is simply a question that has a yes or no answer, or technically a true or false answer. And that's nice because if there's only two possible answers, it's very easy for me and in turn the computer to make a decision. Do this or don't do this thing. Now notice if you come from other languages, you might notice that I have not typed any parentheses. They are not in fact necessary, at least in this case in Python, but I have typed a colon at the end of the line. And even more importantly, at the next line, I have begun my line with some indentation, hitting the spacebar 4 times or just hitting tab once, which will automatically be converted to the same. That indentation is what tells Python that line 5 should only be executed if the answer to line 4's question is in fact true. So if x is less than y, that phrase will be printed thereafter. Well, let's add a few more lines of code. How about another question? If x is greater than y, then let's go ahead and print that. X is greater than y. And let's do one final question. If x equals y, then wait a minute. What have I done wrong here, right? A good eye here. I don't want to assign y to x. If x equals y is how I express equality. Let's go ahead and print out x is equal to y. So I now have 3 conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run Python of compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y, exactly as I would expect there. Well, what just happened, though, in code? Well, let's take a look, perhaps, at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flow chart. It's a diagram of this program's logic, and more technically, it shows the program's control flow. That is, the ability of you in code to control the flow of a program. Another question. If x is greater than y, then question done wrong here, right? A good eye here. I don't want to assign y to x if x x equals y is how I express equality. Let's go ahead and print out one window. I'm going to run y. Let's tell me, indeed, well, what just happened, though, in code? Well, let's take a look, perhaps, at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flow chart. It's a diagram of this program's logic, and more technically, it shows the program's control flow. That is, the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flow chart, and you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape, and inside of that diamond is a question, a Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2 respectively for x and y. So of course, 1 is less than 2. So that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask 2 more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, you don't print anything this time. That's why we only saw 1 print out on the screen. Now, there was still a third question, and this flowchart captures that as well. The third diamond asks x equals y. Now, that too has a false answer in this case, because 1, of course, does not equal y. And so we again follow the third false branch here. And that leads us, of course, to stop. And stop just indicates that's it for the program. So I think that's correct. And that particular flowchart does happen to represent the actual code that I wrote. So it's correct. It does what it's supposed to do. It answered the question correctly by printing on the screen x less than y. But what is perhaps poorly designed about it? Let's make this first distinction. It's not enough necessarily for the code that you write to be correct and do what you intend. Longer term, especially as our programs get longer and more sophisticated, more complicated, we're going to want them to be well designed too. Thoughts on in what way this program is arguably not well designed, even though it's correct? Let's see here. Khalid, if I'm saying that right, your thoughts?
Too many ifs, I think, is getting repetitive. We can make our code more concise, maybe.
Yeah, it seems a little repetitive. I'm asking if this, if this, if this, and yet logically, I should know the answer to some of those later questions once I figure 1 out. And in short, if you look at this diagram here, notice that no matter whether I go left or I go right, I'm always asking 3 questions. No matter what, all of those arrows lead to the first, the second, and the third diamond. So I'm asking 3 questions no matter whether any of those answers are true or false. Well, how might I go about improving this? Well, let me propose that we introduce another keyword to our Python vocabulary, namely elif. And this too is kind of a succinct